get into the basics and the tools of geometry, the foundation, things that you need to know to be successful all year long in geometry. We're going to go ahead and start with this warm-up, which I encourage you to try on your own first. We're going to figure out what kind of, math terms go with these figures. And number one, we just have a dot. Well, we don't call it a dot. We call it a point, and we can name it point Q because it's Q. Number two is going to be array. Array has an endpoint, and it goes on and on forever in one direction, so this will be array. And the name of this array can be FG with a little arrow above it, looking just like array. Number three is going to be a line, and we'll talk more about different ways that we can name this. One way is going to be line XZ. Number four is actually going to be a segment. A lot of times we think of it as a line, but a line goes on and on forever in both directions. A segment does not. It has endpoints. It starts and it stops. And we can call this segment DE. Next, we take a look at 5. 5 is an angle. And the way we can name this is angle A. That's how I make my angle sign. Okay. Number 6, we're going to have another angle, but this time we have more than just one letter, so we can name this, say, angle RST. And then number 7 will be a plane, and we can name it by the uppercase subscript, plane X, or just grab 3 points, just any random point, say K, N, P. Okay, so these are the things we're going to be talking about, different interactions with each other and continuing on. So these terms right here, vocabulary, you're going to have to know these because we're not going to sit there and explain them every time. We're just going to say, hey, line, you're going to have to know, am I talking about number 3 or 4? Okay, and what the picture looks like. So let's start looking at the legit definitions here. Unlike the real world model, points, lines, and planes do not have actual sizes, okay? In geometry, point, line, and planes are considered what we call undefined terms because they do not have an end. This means they're going to go on and on forever. So you're going to go on forever. There's no end to it. Obviously, when we draw them, we have to have an end, but in reality, not like what we can see, but they're never going to end. The first thing we'll talk about is a point. It is a location, a precise location in space. It has no shape, it has no size. Points are going to be named with a capital letter, and it's a capital letter sitting by it. So this example over here, we'd call this point A, or we could just say A. The next one, we have a line. A line is going to be made up of 2 points, at least 2 points, but it's going to be made up of points. Well, we'll see 2 points. It's actually an infinite number of points that it's going to have no thickness, no width. And we're going to talk about a little bit, whenever you go through 2 points, there's going to be exactly one line that goes between 2 points. There are 3 different ways that we can name this. We can use the lowercase script right here, this little M. So we'll go ahead and put that here as the name of the line. Can make it a little curvy like this, like the script. We can pick any 2 points that, word line with any 2 points on the line, and then we can use our symbol with any 2 points right here. And the symbol that goes above these 2 points is going to look exactly like a line. It's got the 2 arrowheads on the end. So with this line, we can name it line M, or we can name it line PQ with that symbol above it, or we can name it line QP. You can pick any 2 points. There's 17 points on there. Grab any 2 that you want to, but only 2. Next, we're going to talk about a plane. Plane is going to be a flat surface. It's going to be made up of a bunch of points. It's going to go in 2-dimensionally and continuously and never stops. There's exactly one plane through any 3 points. If you have 3 points floating around, you have one plane that will connect all 3 of them together. We can name the plane with an uppercase script that does not have a point next to it. That's what you're looking for. So we could call this plane K. Or any 3 non-collinear points. Now this non-collinear point Our non-collinear, we're gonna talk a little bit more about that a little later. But here, we only have 3 points on here, so we can name it plane B, C, D, and it does not matter what order those 3 points go in. You have a lot of free will on the line and the plane with the points that you choose. 2 for the line, 3 for the plane, put them whatever order you want to. All right, so down here, collinear points are points on the same line. And so what we need to see here is in the word collinear, you have the word line. Collinear, okay? Non-collinear is the not part. They do not fall on the same line. Coplanar, I know it's spelled a little different, but P-L-A-N, and then pretend there's an E, are going to be points that lie on the same plane. So you have that plane and coplanar. And again, non-coplanar, not on the same plane. This bottom section, we're going to give three possible names for each of these that they want. We're going to look at A. We're looking at the line containing point W. So we have 2 lines here. We'll look at the one that contains point W. Again, we can call this with the little subscript. We can call it line, this little tiny N that has no point on it. So we can call it line N. And then you can choose how you want to do it. Using V, W, X, and Y, choose any 2 points you want out of those 4 and put them whatever order you want. Just make sure you put the line symbol above it. So we can call this line VW. You could call it line YV. It doesn't really matter. Any of those, any combination of 2 points out of those 4, any order. Make sure that symbol is above it. Make sure the symbol looks just like that. The plane containing point X, so X is going to be this plane that we see. We can name it with the uppercase script of plane P. And then any 3 points that are not on the same line, okay? So here we have to understand that we cannot use V, W, and X. They are collinear. And up here, when we talked about it, they it could be any 3 non-collinear points. They cannot fall on the same line. So if we want to grab V and W, we're going to have to grab Z, okay? So looking at these, we grab any 2 that we have on that line there, and then also Z. We're going to include Z because that one's non-collinear with the rest. So we can call this plane, say, WYZ. We could call it plane, let's see, XZV, as long as not all three letters are on that line N right there, okay? And here I also want to make sure that we specify that point T is not on the plane. So you cannot use point T either. It's way up here, okay? So let's talk about our intersections. We have these different points, lines, planes, all these things. Let's go ahead and, if they intersect, here the first one, or let's first say the intersection is going to be 2 or more geometric figures. They're going to have a set points that I have in common. 2 lines right here are going to intersect at exactly 1 point. Exactly 1 point. Over here we have a plane and a line. These are also going to intersect at 1 point. Okay, the line is going to cut through that plane. And then when we take a look at the 2 planes, you're going to notice here this is the intersection. So what ends up happening is these are going to intersect at exactly 1 line. Make sure you have those drawn in on your images as well. Now, number 2 here, this problem, we're going to go ahead and take a look at identifying different things. Then we got a lot of stuff going on with this figure. Let's take a look at A. We want to know how many planes appear in the figure. All right, well, we got the big flat one right here, right? Well, now we need to take a look at also how many sides that this shape, okay, this we'll learn later, pyramid, pentagonal pyramid has. Well, it has pentagonal 5, and then so we also have the big, large plane that it's sitting on. So here we have 6 planes. We're going to name 3 points that are collinear. Okay, 3 points that are collinear. So So we need to find 3 points in the same line. There's only one option here, and that's going to be right here on the same line. Points J, K, and D. On the same line. No other line contains 3 points here. Name the intersection of plane HDJ and plane X. So remember, two planes are going to intersect at a line. So we're looking at plane HDG. So we're looking at this plane right here. And plane X, the larger one. So we're looking right here. So we're looking at segment HG. And if you want to name it line HG for right now, that is fine, but we will be talking more about segments. They do start and stop. So, and this does have a start at H and a stop at G. So I'll go ahead and name it in this. That's your segment bar. Now we want to know, are points E, D, F, and G coplanar? Are they on the same plane? So let's take a look. Point E is right here. Point D is right here. Point F. Okay, right now these three are on the same plane, this little side over here that's in the back. But now we're going to add in G. G is not on the same. You could say G, F, and E are on the same plane, plane X. You could say E, D, and F are on the same plane, but you combine all four of these, they are not all on the same plane. So we'll say no. And we just put in here the reason why point G is not on the same plane as E, D, and F. Go ahead and pause and make sure you have that written out. Lastly, at what point or in what line do planes J, D, H, J, D, E, and E, D, F intersect? This is going to get a little weird because we know that planes are supposed to intersect at a line, but that's whenever you have two. So now we've got more than one. So let's take a look here. We have planes J, D, H. So here's J, D, H. So we're looking at this front one right here. Plane J, D, E. So from J to D to E. So that's that back one. And plane E, D, F. So go E, D, F. So this one over here. All of them are going to intersect right here at point D. So here are some examples, getting your definitions of your points, lines, and planes so that we can move forward with the geometry basics.